Hi everyone, this is Nikhil from DC Area WX, and today I'm going to be discussing the big time winter storm that's going to be affecting much of the eastern and central United States over this upcoming weekend. The reason I've decided to make a video update is because this is going to be one of the bigger storms we've had really in the last decade, and I thought maybe it would be a good idea to do a little bit more in-depth of an analysis. Maybe people would like that more, but let me know if you don't. This is my first time doing this. I made a hurricane forecast once, but I haven't done this type of analysis, in video format before. So just let me know what you think about it, and bear with me. So right now, what we're looking at is 500 millibar vorticity at hour 66. We're looking at the entire North American continent, and it is Friday evening at the time of this forecast, so just in a couple days. Um, what we see on this map is we see our shortwave of interest right down here, getting ready to make landfall in the Baja Peninsula and eventually eject out eastward over Texas. The other big thing on this map is this huge, sprawling tropospheric polar vortex over eastern Canada. This has kind of been trapped there by the combination of this bridge over Alaska, this ridge over Greenland, which have essentially forced this tropospheric polar vortex way further south than it wants to be. And it's going to be a big player in this forecast for a couple of reasons. First of all, what this does is it generates a really sharp temperature gradient to its south, which happens to be over the central and eastern United States. That temperature gradient means a lot of potential energy, and it really just takes any sort of spark to, start generating precipitation, even if it's not the strongest spark in the world. But we do happen to have a pretty strong one in this case. Player number 3, not really visible yet on this part of the map, but it's up here, and you will see it quite easily in a few frames as I fast forwards. So that's what we're gonna do. As this shortwave moves, as this shortwave moves into Texas, here's the setup now. Part of the tropospheric polar vortex has moved over Newfoundland and Greenland. It is kind of sitting up here, while another chunk of it is now digging into the central United States, whereas the shortwave is still here. Previously, this interaction looked to be unfavorable, and this shortwave to the north looked to suppress our shortwave to the south and just kind of shear it out. And the result was you get this overrunning precipitation, and that's kind of it. Recently, we've trended towards a much more favorable interaction. And so if we zoom in to the United States, just to get your bearings again, here's that southern shortwave, here's this northern one digging in, and now this southern one is actually ahead of the northern one, and so it is ejecting out ahead as this northern shortwave continues to dig. And this is overall a net positive interaction for the two features. And if we go forwards a little bit, you can see the resulting trough axis, which is kind of here now, is amplified compared to just a few frames ago. And this whole thing is going to continue to amplify over time. We've kind of, at this point in the forecast, locked this general evolution in. Favorable interaction, amplification, and eventually a move towards the coast. And so the questions now come down to how favorable is this interaction? Does this southern shortwave still get somewhat sheared out to an extent and end up in a more southern track? Or does it, interact even more favorably and end up way up here or something like that? And it's still hard to say because it's a binary interaction. These can be a little bit tough to predict, especially because the northern stream, that shortwave coming in from Canada, is really finicky. It's been extremely volatile on the models because it's so ingrained in this TPV, which in and of itself is already so difficult to, resolve due to all the little vortices associated with it. And so this is part of the setup that's going to be kind of trending until, 48 hours to go before the storm starts. And we're going to be going back and forth with it. And there'll be a lot of freakouts. That's just how it's going to go. So yeah, that's kind of the evolution from the upper levels. If we now follow this at the surface, we can still see traces, of these upper level features in the thickness gradients. But we'll start off right around here. This is hour 72 on Saturday morning. And so again, you have your shortwave out here, but all this precipitation is already breaking out well ahead of the shortwave, even before this northern piece really gets involved at all. The reason for this is, again, because the temperature gradient is so strong. All it takes is a little bit of warm air advection from the Gulf of Mexico. Generate this thing called frontogenesis, which is essentially where you're just strengthening the pre-existing warm front that's already, present in this area. And then the atmosphere doesn't like that, and so it generates these vertical circulations that end up leading to a big area of rising air, which you can see as this precipitation shield. So I don't know why I chose yellow. That's a horrible color. But yeah, basically that's how this works. It's called overrunning by a lot of people. But yeah, it's essentially just strengthening of the pre-existing warm front that leads to all this precipitation developing. The warm front is slanted, however, and so as we kind of propagate through time, we see this huge precipitation shield developing. But it's not just a rain snow line. You have your snow area here, but then you have your sleet snow line, and then finally a little bit of rain at the bottom. But you have this really big area of ice, sleet, and freezing rain that's showing up on the model. And that's again because the warm front slants with height. You can kind of see that if we look, first of all, let's look at a map like this. This is Sunday afternoon. We are looking at the 700 millibar layer, so this is the lower to mid troposphere, and we can see that our freezing line is located kind of over here as we draw it right around here, Southern Virginia and westward. However, as we go to the surface, if we instead go to the surface, I should say, you can see that freezing line is way, way further south, especially over the Carolinas. And that's just because, again, that first of all, the warm front slants with height, as I was saying before. That's why it's pretty much uniformly south at the surface. But also, especially in the Carolinas, because what you get in this type of setup is this big time high over New England. That is essentially importing cold flow down east of the Appalachian Mountains near the surface. And because the Appalachian Mountains are there, they essentially trap that cold air in the region, even though you're getting warm air advection aloft. And so what happens is you're below freezing at the surface, but above the surface, you're above freezing. That leads to melting, refreezing of the precipitation in the form of sleet or ice. In this particular setup, I strongly think that most of the non-snow precipitation is going to be in the form of sleet rather than ice, or rather than freezing rain, because that surface cold air, the surface air mass is so freaking cold because of the origin of the air mass. It's a truly Arctic air mass. You're going to be in the low to mid 20s, and it's a lot of cold air, even though it's overlaid with warm air. So I think you will mostly be getting refreezing. However, there will inevitably be some band where it is freezing rain, and sleet's already bad, snow's already bad. Those are problems, obviously, but the really big problem with freezing rain is that it takes down power lines, it takes down tree limbs, it causes widespread power outages. And so ideally this won't be as much freezing rain as it is sleet, and I do think that's going to be the case. I think it's going to be a lot of sleet. which is a problem in its own right. But those who do end up in prolonged freezing rain should prepare for significant and potentially prolonged power outages. Refer to your local NWS office for more information regarding that, of course. Um, yeah, so that is kind of the warmer advection part of the storm. This is going to make up the majority of the storm. As you can see, you have this snow, sleet, and ice, and then rain, and over a very long east to west swath. Um, However, what's going to happen is that your precipitation shield is going to be amplified. It's trended a lot more amplified over the past day, and so it's trended to the point where we actually now have some sort of surface low sitting over the southeastern states. What this does is once this develops, it'll enhance warm air advection just to its east, and this will lead to both heavier precipitation but also stronger warm air advection. Two things go together. And so this has been leading towards a trend of more sleet in the North Carolina, southern, and central Virginia region, whereas you get heavier snow to the north of that. And so the amount that this low pressure develops again relates to that upper level evolution we discussed. The more favorable that evolution is, the more the surface low will develop, and the more warmer advection you'll get, the heavier the precipitation, the further north the shield goes. Again, this part's a little bit hard to predict. The one thing we can predict, however, with a decent amount of enough certainty where I'm willing to mention it, is that we're going to get once we get into the range of the mesoscale models, they are probably going to show more warm air advection than any of these global models are showing, for the most part at least. Maybe not like the Canadian, which is really amplified, but they're going to generally show stronger warm air advection, and they usually verify closer to the truth. The globals tend to underestimate that process. And so that's something to note as we start getting into NAM range and we see, well, is the NAM showing significantly stronger warmer advection? If it is, then that's something to worry about as far as maybe rely on the NAM for the precipitation shield more than these global models. But it could also be fairly similar to these. I've seen both kind of verify, so it'll be telling once that gets into range. But otherwise, from the synoptic scale perspective, shifts are really just going to be caused by how favorable that interaction between these two pieces are. And so if you're kind of following this at home and whatnot, that's what I would focus on. The more this combined feature amplifies, yeah, just the more amplified, the more north it'll be. And also, the more of a coastal development you'll get, because as this thing all wraps up, it doesn't get to this super strong, super wrapped up situation, but you do get this fairly neutrally tilted trough. You're getting positive vorticity advection, which is just essentially leading to rising motion in this part of, the Atlantic Ocean, and so you force surface cyclogenesis somewhere around here at some point. And so kind of the evolution of the lows is going to be, you'll have one here, it'll move up here at some point, and then as this trough wraps up, you'll get another one developing somewhere here and kind of going out to sea like that. But before that goes out to sea, it will probably be able to amplify precipitation up the coast of New England. So here is this warm air advection period of time, and now you can see, if you look off the coast of Virginia Beach, you see a surface low developing there. Now that's moving up the coast, and now notice how your ice has really only been limited to this region of cold air damming now over Virginia and North Carolina. Everywhere else, it's more of a rain snow line because we've transformed from a purely warm frontal precipitation axis to more of a backside coastal storm precipitation axis. And so then by this time of the storm, you have a surface low, ice isn't even really happening anymore, and it's just a rain snow line. And this is something that's really going to be enhancing snow totals in New England and the Northeast United States. So we'll see how much that happens. Again, it depends on how favorable the interaction between those two pieces are. And so, yeah, that's kind of what I have to talk about here. Let me know if you have any other questions that maybe I didn't answer. And I will try to answer that for you. Yeah, I hope you enjoyed this format and that it made sense. Yeah, have a good rest of your day.